Good night. My name is Fabian Fernandez, a student in General Mechanical. Then I will present my presentation. One moment, please. Uh, the first law of thermodynamics is a fundamental law in physics that establishes the conservation of energy in closed thermodynamic system. This law based on the idea that energy can neither be created nor destroyed, only transformed from one form to another. The equation of the first law of thermodynamics is a mathematical expression that represents this law and is used to calculate the amount of energy transferred as work on the enclosed thermodynamic system. This equation studies the amount of energy that enters a system must be equal to the amount of energy that leaves the system, either in the forms of work, then the change in internal energy will be zero. The equation of the first law of thermodynamics is expressed as delta equal Q minus W, where the change in the internal energy of the system. Q is the amount of heat transfer to the system, and W is the work done by the system. In the equation of the first law of the thermodynamics, the heat transferred to the system is defined as S Q equal MC delta T, which means the mix of the system. C is the heat capacity of the system, and delta T is the change in the temperature of the system. Is the another second law of thermodynamics gives the maximum friction on terminal energy can be really transferred into mechanical energy, as we'll see this connecting with the question in the which direction the transfer of form of energy to another for processes with time, external action, or experience still the head flow be its own only from the other region into the color of night per person. In the equation of the first law of thermodynamics, the work done by the system defined as W equal a minus P delta B, where this P is the pressure of the system and delta B is the change in the volume of the system. The second law of thermodynamics gives the maximum fraction on terminal energy that can be really transferred into mechanical energy. As we'll see, this is connected with the question into which direction the transfer of one form of energy into another for process by its own with external action. All of our experience deduce that heat flows with its own only from the hotter region into the colder one, not vice versa. Furthermore, all experiments show that mechanical energy can be completely converted into heat, but that for the opposite process only part of the heat can be converted into mechanical energy. Um, QC is equal energy that is absorbed, the subscribed C reference hot. And Q if equal energy that is used, the supercritical reference to cold. Delta U equals 0 because the working substance is taking through a cycle. Its initial and final internal energy is the same, so the coming the excuse me the change in internal energy is 0. Delta U equal Q max W. Q T equal QC minus QF. And W equal divided Q and C divided minus divided Q if see E equal excuse me W divided QC A equal QC minus QF divided QC. A equal 1 minus QF divided QC. COP equal Q netto divided W and cycle. P equal W divided delta T expressed in J divides is equal watts. The third law of thermodynamics is on the fundamental principles of the physics that is responsible for student behavior of the thermodynamic system, abstractly low temperature. This principle establishes that it is impossible reaching absolute zero of temperature, that is to say a temperature in which the entropy of the system reaches a minimum value. An example of the application of the third law of thermodynamics is in cryogenics, with extreme low temperature are used to preserve biological materials and other heat-sensitive products. Another example is in material research, with the law of thermodynamics is used to study the properties of material low temperature. The forward is W equal to QC minus QF, where QF and QC are talking is positive quantities in the substance of bodies and gas. The network done is a cyclical process. The thermal efficiency of matching indefinite as the ratio between their network done absorbed during a cycle and equal to divided QC and equal to QC minus Q if divided by QC and equals 1 minus Q if divided by QC. I had engineered can obtain an efficiency of the 100% only if Q if is I if no heat is related to the cold source. In conclusion, a perfect efficiency must convert all the absorbed heat energy QC into mechanical work. Operating coefficient COP equal Q net divided W cycle maximum efficiency TF divided DC minus TF the power. The Carnot Cycle formula is a fundamental to the thermodynamics that allows to understand the behavior of heat engines and the efficiency of energy process. And Carnot machine, it is the register in a clockwise direction, that the gas produces work the thermal transformation that constitutes the cycle of some AR, excuse me, isothermal expansion A and B, the gas absorbed an amount of the heat QC while maintaining the temperature of the double source T1 adiabatic expansion. B and C, the gas is called wired head, lows to the cold source temperature T2. Isothermal compression C and D, the gas grapes of the QF do the cold source equilibrium changing temperature adiabatic. Compression D and A, the gas is headed up to temperature of the hot spot T1, closing the cycle. Analyzing the graphs, we can see the is equal to the temperature of the hot source and TF to the cold source. The ratio is equal Cp molar specific heat at constant pressure divided Cb at constant volume. Analyzing the adiabatic processes B and C, the temperature at point B, which is the seat multiplied by the volume B and B, range minus on the B and B raised to the ratio minus 1 equal to if times BC raised to the range minus 1. Parallel process D and A, which is the adiabatic temperature at point is the Tc times B and raised to the radio minus 1 is equal to temperature at point BTF BD raised to the range minus 1. Dividing the two expressions, cancellation the temperature be taking the root of R minus on B and B on B A equals B and C on BID. We obtain the relation volumes. The isothermal process CNQF the work done Q and if equal W in RT temperatura natural logarithm volume change QF equals W equals NRT if natural logarithm BC or over BD. In the process C and D, the temperature is the phase and the processes A and B, the temperature is Tc, clarifying the hair without the absolute value of these heads. Q and C equal W equals in RT, C natural logarithm, B and B over B and BA, the expression are divided in these two processes obtain a relationships in between the heat of the cold source divided by the heat of the hot source. QNF over QC equals TF over TC natural logs of BC divided by D over natural log of B and B divided B and A. We returning to the volume equation to the logarithm expression is equal to 1 and the heat ratio is equal to the temperature. Ratio remembering the efficiency equation, we replace the heat ratio in relation to the temperature functions. It is given the equation of heat efficiency and equals 1 less QF over QC. EC equals 1 minus TF over test. Thank you. Good night.